Hello friends, welcome to the Laptex. My name is Nasir and today we will see a case study of LA-8131P. This is the Lenovo motherboard and today I will describe you how you will check dead laptop and how many things you have to check. As if you have gone through the our video classes, then you must have understand the switching concept. However, the purpose of making this case study is that the different charging concept is there. Different PACIN section is coming from the op-amp. So op-amp and all type of switching concept is shown in our video sections. So if you have watched that, so your concept would be clear, and if you haven't seen that video, you can contact on the given number and you can avail that video also. So now let me inject the DC jack into the motherboard and see the what is situation. Now you can see 0.061 milliamp is the load of current consumption. Now if I show you the scenario of the board, so let's see 19 volt in the DC jack area. Do you have the DC in voltage or not? So here let's come and see on that area which is called sensing register of the DC in. Here we are not getting any voltage. However, on the DC jack you can check the 19 volt. This is 20 volt. It is available on the DC jack. Now let me open its diagram and so guys, this is the diagram of this model of Lenovo, and now the DC in section we have to trace. Here is the sensing register, which number is PR302. PR302. Now this is the DC in section. Here it seems that something is short in the board as it appears, but what is our working concept that we need to check how many voltages are available on that area. We will check shorting also, but this is the scenario. This is the DC in area where we have to check VIN on the PQ301. Let me zoom it. 301. So unfortunately this particular model has no board view, so we will have to trace and we have to check like this way. Now let me show you 301. This is the 301 and the MOSFET number is 4407. This is the P channel MOSFET, and as we have discussed in our class that what is the biasing of this P channel MOSFET and how we will calculate the DC in sections. Here only I will tell you the one important point here. When the PAC in will come here and the ground will reach here, and here it will become a divider, and through the divider the voltage will enter into the gate, and then we will get the biasing voltage, and this is the blocking FET and this is the switching FET. So through the blocking FET, since it is the diode mod, so voltage will go across it even if it is not switched on. But if this is not switched on, this voltage will not go across this MOSFET. Okay, so let's check 301 first and see what is the condition of the FET. Now I'm going to check the pin number 1 or 2, whatever you can check. So here it is 20 volt. Good. On the gate it is also 20 volt. That is not good. On the drain side it is 20 volt. All side are 20, so it is not good. The other one is PQ304. Okay, PQ304, and the same thing we will check. Pin number 1, it is 20 volt, and so gate 20 volt, but this side should not be voltage since it is the blocking diode. The diode you can see here, it is on the blocking mode. Okay, so the voltage cannot pass on the diode mode if it is not switched on. So what is required thing here? PACN. Okay, PACN will come here, then it become a voltage divider, then the voltage will go here, which is not going. almost what we are getting here, 20 volt on this side, 20 volt on this side, as well as 20 volt on this side. But if you look very closely to your multimeter, then you will find here some difference voltage across the diode. Okay, so if 20 volt is here, exactly 20 volt you enter through the drain side. On this side, 19.3 volt around you will get on the source side. Okay, so we need to check PACin, where it is coming from. Usually we have seen through the AC OK logic. So it's depend on your architecture that it might come out from some else area, like op amp is used, some BJT is used, or sometime it comes out from SIO. Here the AC OK is crossed, CPMIN is crossed, COM-PART is crossed. So here there is no working concept for charging IC is not responsible to switch the primary and secondary MOSFET. Okay, so let's copy this particular point, PACin, paste it, and see where is it coming from. So this is the point through the op amp it is coming. Now you can see this is the PU101A and the name is LM393DG underscore SO8. So this is the 8-pin IC, and this is a kind of op amp. However, if you have seen the video of Dildar sir, there is the concept of inverting amplifier, non-inverting amplifier, differential amplifier, and relaxation circuit, and also one thing is that is the oscillator. So here it is working as an oscillator, and now the oscillator concept is slightly different from the inverting and non-inverting concept. So here is only thing that you have to check the feedback, the inverting feedback and non-inverting feedback, which one is the greater. Now here is the calculation that voltage divider is set here. If this is greater, if this is greater to this value, the RTC value, then surely you will get saturation voltage, VS voltage. This is the saturation voltage, this is the cutoff voltage. Definitely you will get the saturation voltage on this point. However, this concept we have discussed in our class. There we have described that how you will calculate Zener diode switching value and this divider, how these things will work and when this thing will work according to the feedback. So here only thing I will tell you that if the positive feedback is greater to the negative value, then this saturation point will come to this point. Otherwise the cutoff voltage will go here and 0 volt you will get if negative is greater. So here is 2 number and 3 number you need to check on this particular point. So now let's come and check PU101. Let me find it. PU, no, this is the one LM I have got. So now let me show you. Okay, let me clear it. So this is the LM393, and what pin I need to check? 2 number and 3 number, which one is greater? Now let's check 2 and 3. According to that we will get voltage here. If negative is greater, then 0 voltage we will get here, and if it is greater, then the saturation voltage we will get. Now 2 number first we need to check. This is the 2 number, and we are getting voltage 3.28 volt, 3.3 you can call it, 3.3 volt we are getting on the pin number 2, and pin number 3. So pin number 3 is 3.9 volts. So of course this is the greater value. Okay, 0.6 millivolt is greater 3 number pin from 2 number pin. So definitely on the pin number 1 we will get the saturation voltage. Now 3.2 volt PACin we are getting on this point. So the 1 number we have checked, this is what we are getting on the pin number 1 as you have seen. Let's see again, you will understand, but the entire concept of switching you will only understand to see our class video. Okay, so if you are interested you can contact on the given number. So 2 number is less, 3 number is great, saturated voltage is greater to the cutoff voltage, so that is why you will get 3.2 volt. That is the VS voltage which is used as a PACin and going to switch on the primary and secondary MOSFET. But despite our MOSFET is not being switched, what could be reason behind that? Now let's find out. It is also going on this op amp, and we will also calculate this thing later. Okay, so first of all we have to check this PAC in or AC in raised to the target point or not. So here is a PQ310B. So maybe 6 terminal 6 SOP, and we need to find on the board. So maybe on the DC area nearby PQ301. So now let's come and find PQ310. 310. PQ310. PQ310 is here. Now this is the PQ310. Here pin number, this is the marking, this is the marking pin number 1. Okay, what we have to check here, we have to check 5 number and 2 number. So let's check 5 number and 2 number. That must get voltage if PAC in has come out from LM393. Okay, now 1 2, no voltage. 5, let's come and check 5, no voltage. So across a register it is coming, that is the 47K register. So we need to find out like this way, because we have, sorry, before checking I was not using DC in. Yes, now I have injected DC jack. Let's confirm again. Pin number 5 and pin number 2. Pin number 5, 0.24, 24 millivolt we are getting here. On pin number 5, the same voltage we are getting on the pin number 5. So the 2 number is connected with this point, this register. So that must be this register. So first let's check and what is the value of this register. Now let's come and see. Let me set multimeter to the ohm. Now let's come and find out. This is 0 value, so absolutely right, this is the very register which we have to check the value. Now 42 kilo ohm, so from the other side it is 46.7, so it is around 47 kilo ohm. Register value is absolutely right. Now let's check the same voltage. Let me insert the DC jack into the board. Now check PAC in has reached on this area or not. Let me set my multimeter to the voltage mode. So this side we are getting 3.2 volt, that's good, but this side we are getting no voltage. So here we can conclude that nowhere it is going except one area. This is the PQ310 A or B, both are the in same package. One more thing, it is also going to the PQ311, that might be faulty. Also it is going anywhere else, that also could be responsible to stop this PAC in. Okay, so this is the area, but there is also one register 47 kilo ohm, so might be faulty. So what I will do here, I will just remove this PQ110. PQ110 I will remove, and I will check that whether I get voltage across the register or not. So now let's come back here and remove this. Maybe this is leaky. One thing we must confirm, that is it short or something. So now let's confirm it. So set it on the beep mode. No shorting. Now let's remove it. So it is not necessary that this is faulty, this could be faulty. As I told you that wherever PACin is going could be faulty, but actually we have received on this point. That is why I'm going to remove this one. Before the register, we are getting voltage. So we have removed this transistor from the board. Now I will check the same register. Do we get voltage or not? So still the ampere is same, and let's check, do we get voltage on this terminal or not. Here we were getting, still we are getting. Now on this side we are not getting the voltage. So it means that maybe this area wherever it is connected PAC, see here, this particular point is also connected with this area. Okay, so PAC in wherever it is going, we cannot say it is having any problem. After this register, we are not getting voltage. So we have removed this one. So there is no concern about these area. Now we have left this transistor. Or one more thing, if AC on is grounded from some point, so maybe that could stop this PAC in. They are the responsible to stop PAC in. Now one by one we have to find out. At least we can confirm here that PQ310 has no problem at all. So let's put it back. Okay, this is what is the process to make it confirm. Now let's bring back to its place. So we have placed back the transistor. Now what else we have suspect, that is the PQ313, PQ313, 313. Now let's remove it. If before register we do not get voltage, even if everything is okay, then we could suspect all entire PAC okay. Now it seems the condition is still same. Okay, we are not getting voltage on this point. So now what we are going to do, that is the manageable work. Here we are forcibly trying to enter this voltage. Now do one thing, we have through the diffuser, we are going to inject the voltage across the resistor. Now let's check what voltage we are getting on this point. I think my diffuser is not good. Let me change it. So still we are not getting anything. It is going to reduce entire voltage. Even back voltage has gone. Now you can see on this side I am checking, no voltage is available here. So it means that there is something which is having problem. What I am going to do, so let me do one thing, that let me place back this transistor, this NPN, and you have to tell me that what is causing to stop this voltage, because you have seen that forcibly I have jumpered even if this is not working. So now let me place back. Okay, so now tell me what could be reason here that this voltage is not going across the resistor, because let me show you that this particular area impedance. Now let's check, it is open, this side also this is open, no shorting at all. Okay, So this is not short despite the voltage is not going across the resistor. Why? So guys, please comment on our YouTube comment box that what else is left here, because if I am trying to forcibly give the voltage on this area in order to switch this MOSFET, also this MOSFET, but still the voltage is going to reduced even the PACN. So you must comment what you think that what could be the problem. So inshallah in next video we will give you the solution of this video. Thank you guys. Thank you for watching this video.